Welcome to lesson 8.2, solving for sides with trigonometric ratios. That last lesson, that was baby stuff. Now we're about to get real by finding missing sides. And to be real with you, this is the things that the ancient Greeks were using to find, how far the Earth was from the moon, and a lot of interesting things. It's a very powerful thing, trig. And you'll find out more about that in this unit, in Algebra 2 and Calculus. It's very, very cool math. So let's start with the basics here. We want to be able to find the missing side of a right triangle. And I'll tell you this, if you know one angle, all right, and not the 90-degree angle, one other angle, and one side of a right triangle, all right, you can find any missing side of a triangle using trig, all right? And the way you do it is you follow these steps. So for example, I want to find x in this triangle, ABC, x. The way I'm going to do that is first I'm going to label my sides like I did in my last lesson. So here's my angle. That means that across from it is our opposite, so x is our opposite, and 12 is our hypotenuse. All right, and we don't have anything for adjacent, so I'm not even going to label it. So I have O and H. Now I can start solving. The way I'm going to do it is first identify the trig function. So now that I have my thing labeled like I did in the last lesson, I'm going to identify which trig function I'm going to use to solve this. And the way you do that is, let's write out SOHCAHTOA. SOHCAHTOA. Alright? If you notice here, in the problem we have opposite and hypotenuse. So which of these trig functions should I use? Which one of these has opposite and hypotenuse? Well, that would be sine, right? So let's use sine in this, all right, because we have opposite and hypotenuse. So sine is our trig function, and that's the most important thing, picking the right trig function. You really got to pay attention to which trig function you use. So you have opposite and hypotenuse, you're going to use the sine. Now we do the sine of the angle measure we're given, so we're going to use the sine of 30, we plug in our angle, equals, well, opposite over hypotenuse. Remember, opposite over hypotenuse. So that's x over 12. Here's what you do to solve this problem. What you're going to do is rewrite it as sine of 30 is over 1 is equal to x over 12. From here you're going to cross multiply. And you get 12 times the sine of 30 is equal to 1x. Alright, and I don't have to write the 1, so it's just x. And now this is where you grab a calculator. And you need a calculator to do this lesson. You cannot do it without a calculator. So grab a calculator, all right? And what we're going to do is we're just going to put this in. 12 times the sine of 30 will give us x. So we do 12, turn it on. 12 times the sine, and I know you don't have this calculator, but all the calculators in the room will have a sine button. The sine of 30, close parenthesis. All right, so I just put this in, and that gave me 6. So our x is equal to 6. All right, and that is how you use trig to find the missing side. Let's do a few more practice examples. So in our second example, we're going to find the length of BC. So the first thing we're going to do is put an x there. All right, BC, let's put an x on what we want to find. Now we're going to start labeling. Like I said, we want to label. So this is our 60-degree angle. Across from that's opposite. We don't have anything there. And across from the 90 is 20, so this is our hypotenuse, right? Because that's across from the 90-degree angle. If this is our opposite side and this is our hypotenuse side, x must be the adjacent. All right? Well, now we're going to figure out which trig function we're going to use. So you might remember, I'm going to write down SOHCAHTOA. And which two do I have? I have adjacent and I have hypotenuse. And that relates to cosine. So we're going to use cosine for this problem. So the cosine of the angle that was given, so that is 60 degrees, is equal to adjacent over hypotenuse. So that's x over 20. All right? Remember what I said about solving it? The cosine of 60 over 1 is equal to x over 20, and you're going to cross multiply. So we get cosine 20 times the cosine of 60 degrees is equal to 1x, and we don't have to put the 1 there. We take out our trusty calculator. 20, I'm just putting this in, times cosine 60 is equal to 10. All right. Nicely done, nicely done. All right, so x BC is equal to 10. We did it. Well, keep trying. Let's do another one, okay? Let's just get real good at this. We want to find the length of DE. All right, and we're going to round our answer to the nearest hundredth. All right. So DE, we're going to put our x there. And remember, we're going to label what we have. So 70 is right here. Across from it is x, so that is our opposite. Our 90 degree across from the 90 is here. It's our hypotenuse, and we have nothing there. So that means 5 must be the adjacent side. All right, so we have opposite and adjacent. Let's write it out. SOHCAHTOA. If we have opposite and adjacent, this is going to be the tan function, right? So we're going to use the tan function. Tan of 70 degrees, we put in the angle measure, is going to be equal to opposite over adjacent. So that's opposite is x over adjacent, which is 5. Now we just go back into solving. So tan of 70 over 1 is equal to x over 5. Cross multiply. 5 times the tan of 70 is equal to 1x. Grab out our calculator. And let's do it. So it's 5 times the tan of 70. 5 times tan of 70. And we get 13.737. And we're going to round this to the nearest hundredths. That's the second decimal place. And since the one behind it's a 7, our answer is 13.74 is our x. Oh, nice. So DE is equal to 13.74. If you don't believe me, let's just look at that calculator again. Why is that all the way over there? You see, 13.737, we round it up, so it's 13.74. Remember, it's the second decimal place. You might want to put a note to yourself, just in case you forgot that, second decimal. There's going to be a lot of decimals in this lesson. All right, now let's do some kind of real-world problems, okay? Some like word problems. Now, you hate word problems, but just follow along, we're going to be good. A tree cast a 25-foot shadow on a sunny day, as shown in the diagram below. If the angle of elevation from the tip of the shadow, which is right here, to the top of the tree, which is right here, is 32 degrees, okay? What is the height of the tree to the nearest foot? All right, so this is really just a triangle here, what we were given. All right, so let's draw our right triangle. And it's asking us what the height of the tree is. So if the height of the tree is over here, this side is our x. Well, now we're going to do exactly as, since we have a triangle and we have one angle and one side of a right triangle, we can use trig to find the length of this tree, the height of the tree. Let's do it. So opposite the 32 degrees, we have our x. So that's our opposite. Opposite the 90 degrees, we have nothing. So we're just going to leave it blank. And if over here, down the bottom, since it's not the opposite, it's not the hypotenuse, this is our adjacent. All right. So we write out SOHCAHTOA, S-O-H-CAHTOA. And we're going to figure out which of these functions do we want to use. We have opposite and we have adjacent. Well, opposite and adjacent is our tan function. So we're going to take tan of our angle measure. So it's 32 degrees. Is equal to opposite, which is x, over adjacent, which is 25. Well, let's solve. All right, so we have the tan of 32 over 1 is equal to x over 25. 25 times tan 32 is equal to x. All right, let's take out our trusty calculator now. And we get 25 times tan 32. Enter. And we get 15, and we'll get this decimal. And so let's go look at our question again. We want to find the height of the tree to the nearest tenth of a foot. So the tenth is one decimal place. So we're going to do 15.6. And we don't round up because there's a 2 after it. All right? So that's x equals 15.6. So So that is the height of the tree. The tree is 15.6 feet tall. Nice. Let's keep going. Let's try another one of these. All right. Ladders. They love ladders in trig for some reason. I don't know why. So as shown in the diagram below, uh, a ladder 5 feet long leans against the wall to make a 65-degree angle with the ground. All right. Find the nearest tenth of foot the distance from the wall to the base of the ladder. So the distance from the wall to the base of the ladder. So where are we going to put our x? Well, here's the wall, and here's the base of the ladder. So that's our x. It's very important to underline and read these questions carefully so you know what side you're looking for. So we have a right triangle right here, as you can see, and we want to find this distance. So we're going to do what we always do. We're going to label. So here's our angle. Opposite that angle is nothing, so we're not going to label it. And opposite the 90 is 5 degrees. So that is our hypotenuse, opposite the 90. Since this is opposite in this hypotenuse, x must be our adjacent. Okay? And so now we write out SOHCAHTOA, SOHCAHTOA. And let's see, we are given the adjacent and the hypotenuse. That is our cosine function. So it's the cosine of 65 degrees is equal to adjacent over hypotenuse, x over 5. All right, let's just do the math. We're getting better at this. The cosine of 65 over 1 is equal to x over 5. 5 times the cosine of 65 is equal to x. So let's grab our calculator. All right, our math problem is 5 times the cosine of 65. 5 times cosine 65. Close the parenthesis, and we get 2.11. This question said to the nearest tenth of an inch, so that's going to be just 2.1. So x is equal to 2.1, and we always answer in a full sentence. So the distance of the base of the ladder to the wall is 2.1 feet. Yas. All right, last problem. Let's try this one again. There's no picture given. Well, guess what? We're probably going to have to do it ourselves. So a ladder leaning against the wall, at least it's not a ladder, love ladders, reaches to a height of 12 meters when it's at an angle of 67.5 degrees to the ground. How far is the foot of the ladder away from the wall? So we have a wall. Let's draw a nice little wall right here. Okay. We have a ladder. So this is going to be our ladder. All right. And let's say this is the ground. Let's read this question one more time. A ladder leaning against the wall reaches to a height of 12 meters. Well, that means the height is right here. This is our 12. So this is 12. From the top of the ladder to the ground is 12. It's very important that you label these very carefully. The angle is 67.5 degrees to the ground. So here's the ground, and so the ladder and the ground make 67.5. How far is the foot of the ladder away from the wall? So this is the foot of the ladder, this is the wall, that's going to be x. Alright, just like the last problem almost. Now that we've drawn a sketch, and if they don't have a sketch, you must draw a sketch to answer these. We can answer it. Now if I were just reading this randomly, I would say this is a right triangle because the wall's straight up. Alright, I have one side and one angle. So I could use trig to solve this problem. It's important to know when you can use trig. Well, let's start labeling. 12 is across from our angle, so that is our opposite. Across from the 90 is nothing, and x must be our adjacent then. If we have opposite and adjacent, I'm not even going to write SOHCAHTOA. Actually, I am. SOHCAHTOA. I know that's O and A, so we're going to use the tan function. So the tan of 67.5 is equal to opposite over adjacent. We set up our equation again, so tan of 67.5 over 1 is equal to 12 over x. And now we cross multiply and I get x times the tan of 67.5 is equal to 12. Now I know what you're saying. Well, don't we have to solve for x? and x has this pesky tan on it. Pay attention carefully because this is what you have to do. If it's x times the tan, what you need to do is divide both sides by the tan to get x by itself. So the tan is 67.5. Let's divide that on both sides. Tan is, and what you get is x is equal to, you always have to get x by itself, 12 over the tan of 67.5. And to solve this, we're going to put it in the calculator. So we're going to do 12 divided by the tan of 67.5, close parenthesis, and we get 4.97. This question says, how far is the foot of the ladder away from the wall? Well, you know what? I'm going to just say round this all up. So if 4.97, let's just say 5. So our answer is 4.97, which is really close enough to 5 for me. All right, so the ladder is 5 meters away from the wall. Yes. All right, guys, that's it for this trig lesson. Hopefully you got it down. Now go kiss your mother. I'm telling you, you should do it every day.